for by your program at runtime. In other words, when you declare a pointer and use in C malloc or calloc, this is a memory which is allocated outside the memory allocated for the program somehow. You get extra memory, and that memory is allocated at runtime, so you don't know the address before the program starts. Okay, and for this type of memory, it's very useful. It gives you access to a large pool of memory, but it comes with responsibilities. As long as you do the allocation, you are required to do the deallocation. And there are many other issues. Memory leak is if you forget to deallocate memory. Dangling pointers and some deallocating a memory which was already returned to the system. These are the three most common mistakes people do with pointers, and of course trying to access objects which were not allocated for. Anyway, these were the tools used for C. It makes sense to work with not individual pointers, of course. You normally work with an array, like here, an array. You allocate memory for 10 integers, ZCs, or 10, 100, or 1 million. It's very unlikely to use pointer just to one item, but it happens. So these were the tools in C++. We will reuse some of them. Dereferencing, accessing the value to which P1 points, is something which is continuing to be useful in C++. Remember, I don't know whether you were aware of the fact that after you deallocate memory, it's a safety way to set your pointers to null in C. What is null? You have worked with null? Yeah. In C. It's a constant set to 0 or something. But what is the meaning? This is the syntax. Null is a constant set to 0 to work with pointers.
There's nothing allocated to it.
So it's a pointer which does not point to a variable. It doesn't link to any memory for a variable. So this is a safe way. After you deallocate something, it's good to set it to null just in case someone tries to work with that P1. It happened before, it will happen again. So it's a safety, not a requirement of the language, but it's a safety approach to work with pointers, and we will reuse this one. But in C++, there are new things. First of all, instead of free, we use new. And new is clever enough to know how much memory needs to allocate for 10 integer or for an integer. It doesn't need size off and stuff like that. This is one advantage. New is using contextual information to allocate enough memory. So it makes our life easier. One thing. The other thing is you will see work with whatever you define for your types. So it's safer, simpler syntax. And we don't need castings like before in C. And then we work like you have seen in C language to access individual elements, either with dereferencing or using the index notation. And then when we are done working with that memory, we use delete, and we have two forms for delete. For new, we have one form. But for delete, to delete memory allocated for one item, you just use invocation for delete with round brackets and pass a natural value. P1 is deleted. T1 was an individual thing. But when you want to delete a memory allocated for an array, you have to include these brackets. This is the only thing you have to remember. Like a rule of thumb, as many new you have in your program, the same number of deletes you have to have. Otherwise, you have memory leak. In C++, null is available, but is to be avoided. A null pointer, which is another tool introduced to avoid ambiguity, because null sometimes defaults to zero. There are problems when you use functions which can call pointers and integers. Confusion, ambiguity arises. In C++, null pointer, which is a specific type, we will see, is to be used. So do not interchange new and free. Do not interchange allocate with malloc and delete with delete. Keep them separately because they work in different ways and you get into trouble. I said that in C11 we have null pointer, which is not a macro like null used to be, represents a pointer type which has the same meaning like null. Pointer type which does not link to any meaningful value. But it's making the use of this pointer literal easy, and we can avoid errors. So it's not an integral type. This null pointer is the only value in null pointer underscore t. It's a type which was introduced especially for this to distance the null pointer from zero. And with this introduction, we have no ambiguity when we work with print for integer or print for pointer to int, and we pass null pointer. So if you have to overload function for pointer types like p to a pointer to float, p a pointer to int, most likely you will have to overload your function for null pointer underscore t, just to make sure that this function will work with null pointer. So when we invoke print with null pointer, this is not called, this is not called, only this one is called. So, scope is where a variable has meaning. In other words, you can use it safely. So there are cases in which your variable was outside the scope and you try to access it. Some compilers allow you, but the value there is not defined by the standard because your variable is outside the scope. And in principle, there are two groups: global variables and local variables. Whatever is defined outside every function is a global variable, which are to be avoided. So assume that we have just main function and this is the whole program. This is a global variable. We have the tendency to reuse names, and as you can see here, we have three variables with I. The inner variable is this one, and always the inner variable hides the outer variables with the same name. Inside this for loop, only this I is used. This I, it's available here and after the for loop. But you can't access it inside the for loop. The way, if you want to access it, you have to change the name of this variable. Okay? So if you use for integer j less than 3 plus j cout j, then you can display cout I. And this gives you a handle here. Otherwise, you will see there is no way to access this one. But we have a handle to the global variable. And the handle to the global variable inside any scope is with an operator made up of 2 columns. This is called scope resolution operator because it re-enters a scope which was used for defining a variable. So in the previous program, notice that I put here the I preceded by the scope resolution operator. This gives you access only to the global variables. This says, okay, give me the global variables here, and then this will have that value. Therefore, with this for loop, what is displayed is 2 and 0. Next time, I is 3, and we are out. Right, so there is no way to get a handle to I inside this for loop. As I said, you have to change the variable name. C++ namespaces is a method to partition the global space in which many things live in order to allow us to reuse names. Different library providers have the tendency to use the same name, print or size. And if you use 2 different libraries and you have the same name size, the compiler doesn't get confused, doesn't know which size you mean to use. Therefore, this way of decluttering the global space was introduced by C++. We will see Java uses packages a different way, but very similar in the approach. Right. This was the introduction of C++, 98 or something like that, a late introduction. Right. In C++, most facilities coming from the language come in the standard library, std. Every file in the library provided by according to the syntax of the language, come with this namespace std, and then they have whatever functions, whatever classes, and close the curly brackets. So everything is provided in this iostream.h file and implementation files. They are all before their code. They have this namespace std. We don't create our own namespaces, but in this way, everything which is included in this file can be accessed with a special syntax. First of all, by including the file, providing the tool from the library. So we are talking about cout here and endline. These are provided in iostream. And to give access to our program, to everything there, we have used this using namespace std. As we are sure that we are not going to have cout again from other files. So this will allow us to use the tools provided in iostream with this syntax using a keyword, namespace keyword, and std as standard library shortcut. the name it's used there. Then some people say, oh, you might get into trouble because you might use different tools reusing some names. So it's better to give precise access. You need only cout and end line, cout and end line. Then you should give access to your program only to these tools using STD, globe resolution operator, scope resolution operator, as you can see, cout. So instead of using the whole namespace, we give access here from IO stream to these tools. We precede every item with that. This is somehow a medium level of security. It's more secure. We don't give access to the whole thing. And the most secure, they say, is to use it like that. And probably you have seen code like this. I think that for the moment is a little bit too tedious. Whenever cout is used, you precede it by the namespace, STD. We use sout with that. We use end line, and you have to precede it by the namespace. So there are three syntaxes. We will use the first one, using namespace STD. But when you encounter something like this and you want to reuse the code, you can put using namespace STD, delete this, and you are okay. It's very tedious, it's very useful for very important programs, maybe, dealing with a lot of different library files, but not our case. And the last item we are going to talk about is static variables. They are variables which have a scope sitting between local variables and global variables. So static variables are local variables. Counter is a local variable defined inside the function, but it's allocated, memory is allocated before main starts, like global variables. This is one feature. The memory for these static variables is allocated before the program starts running, because the system reads the function and finds that this is static, okay, it's there. The second feature is that this variable, it preserves its value between functions called. So we will see. The third feature is initialized for us. We can change the value, but if we don't put any initialization, static variables are initialized to default values. For example, for integer, the default value is 0. So the first time when the function is called, counter is initialized to 0. Here is incremented by 1. We get 1. We return 1. When we call again the function, that 1 is a value in our counter variable, initialized by 2. 2 increment by 1, we get counter to be 2, so 2 is returned. When we call the function the third time, this will get the value 3, and 3 is returned. So as you can see, these static variables have a special kind of status. They are not as strong as global variables, but not as weak as local variables, because they preserve their values between functions called and they are initialized. We will see that for classes, they have a special meaning. And if, for example, here we have a static int counter equal 2, we can initialize ourselves. Then, the first time when the function is called, counter is 2, is incremented by 1, there's a value 3, 3 is returned. Next time when we call the function, Z3 is stored in counter, and it's increment to 4, 4 is called, and so on and so forth. Of course, these static variables can be of any type, not necessarily of int. They can be strings, can be float, whatever you want. Right, so we have seen that new and delete are used for pointers, and we will practice with them in the future lectures. Static storage is something you have to be aware. It's not global because you can't access counter outside the function. Okay, so if I have main somewhere, I invoke the function, it does a job, and then in main I invoke counter. No, no, no. Counter is not allowed in main because it's not declared in that scope. So be aware about these bits and pieces, and namespace, which is used to prevent name conflicting, in particular in large projects for which C++ is suitable. And then we are going to remember a little bit what we have talked about, and this was functions and function calls, call by value, call by reference, default values, and static variables, the topic of today. So I would like to have you think about this small quiz, which I put it there, so have a go. Right,
No.
So, let's see. How are you doing with this quiz? As I told you, one question out of 3 for the term test is about this, call by values and call by references. May I have, okay? Yeah. There are any left over quizzes? Yes, may I have here? Yes. So you will keep this, of course. Please, you can write your computation on that piece of paper. So what is the output of that small program, which I have copied here, to find out how much you have understood about call by references, call by value, default values, stuff like that. And you have 5 minutes, and then we will talk about solution. Done? One more minute. right, now you can talk. You can make 2 groups and discuss what is the result. For groups of 3, you can go on 3 and what you have got and why you have got that. Can you get together with someone else and try to find out what they
应用吧，这个，它这个应该是就是相当于把这个先在上面写一下，对吧？但这想应该是一样的。
他要先在上面声明，
对，就是声明啊，但是这两个应该一样。
他底下才能够那个。
对，那这个语义是什么意思？
他第一次就，他第一次
int 意是什么东西
You have 5 minutes to talk about this, and then we will try to go and see what was the problem.
然后这个应该是取地址是吧？
不是，
Agree on an output. What is the output? Can you talk 5 minutes?
哦，上节课我还没复习嘛。这 reference， 我不就那 reference x 是什么？
reference 好像是就是它等于 reference x 等于翻译的话就是它是复制体的。copy 它呀，
那这边传了一个 a 过来，这边为什么会有2个变量？
就是你要是 a 的话，就可能去找这个，好像是这么。
找哪个？
找这个
那2到哪呢？2到这儿。
我想的第一次它就是传那个过来。
2到这儿。那这是什么？
可能就直接到这儿吧，我觉得。其实我也有点没搞清楚这个引用，你这么一说，可能跟我想的好像。
static 是什么意思啊？我忘了。
它 static 就是先调那个方法，它预先加在比 main 更先加在
放前面啊。
哎。
比 main 预更先啊？比 main 还要先加？
对，就是它是系统先读它嘛。
那就是 a 是3了，然后 a 变成2，那也没有什么意义。那是仅加载这一句话吗？还是说整个程序先加载一遍？
就是这一句。
可是他现在讲那个我也有点没清楚。
那你们作业现在做的怎么样？作业做的怎么样？
写完了，他写完了。
啊，写完了就行。
可以那个发给我读一下。
可以啊，邮件。
邮件啊。
哪个时候不会？你们对呀，静态 A 是3的话，那有毛用吗？这个词是什么意思啊
？static，
你这个是静态变量，
你为什么贴个这个全台工程师3？
这是别人的
就自我鼓励是吧？
不是，这是我的方向。
不是，我觉得贴的不好，你看久了你自己就烦。
这个设置有点得劲了。
我主要是把那个镜头贴上。
邮件方式，我的桌面居然这么整齐，我发觉了吧？
这很乱啊！
然后桌面没东西。
用点插件嘛。
他这玩意儿没有插件，
都是自己拉的。
苹果没有那玩意儿，
你这个都是自己摆的对吧？
这是 Steam 上面的一个东西，你把它下下来可以用。
然后你把那个放在了右边，那个菜单栏是吧？放在了右边。
就是下载的东西都在右边。
就是底部那个。
它有一个排。
那 statistic 什么意思 ？static。
就是静态。
哎，邮件给你没发出去，没有吧？
直接发送给我吧。
Messy， 你为什么不是 Messy Student 啊？现在是。
我给你什么？微信？你在这儿呢。这个代码这个东西就是细节，不搞晕。你作业没有写吗？
我写了一点点，我把这个大概框架搞出来了。反正 OOP 嘛，就是一个任务分开来完成。你先搞一个函数打自己的姓名，你再搞一个函数把那个什么没有选课的人搞出来，再搞一个函数打那个。
分着搞的。
你们不是分着搞的吗？
你如果全部写在面里面也可以的，但是不美观。
不是，我们这门课就是 OOP 啊， OOP 它的意思就是让你把它弄成以对象为模式的这种编码方式。
是这么点，他是说那个方法就是方
所以
分开写的。
你不是分开写的？
我有2个合在一个方程里面，有一个单独的。
哦，也行。
因为没办法，因为我确实不会返回那个数组。
哦。
我不是那天在问你们，我怎么返回数组，这是不会。我问那个 PhD 那个，
他都不会，
他自己都不会。
这是个胖子。
我们就是做作业嘛，他不是放几个题吗？不就？问他他不好。
出来没事，搜一下。我记得是静态变量的。
你直接打 Safari 不就？用 Safari 然后搜，估计全都是专业的回答。你直接百度里面搜那个 state。我觉得你在百度里面搜比较好，因为你这个是专业词。
静态变量啊？
啊，静态啊。
你这网页文本首页还是好1、2、3啊，兄弟。很复古，怀旧。
想。应该就是静态的，缩短不行，
静止的，
不变的，
静态变量。
我记得是不变的，它一直不变。
就是说这个 A 永远是3。
它后面就是一个预行夹带，但是具体的我也有点忘了，我后面没用过这个东西。
没有用过这个，
后面都不用。
Would you like anyone to go and explain your? Anyone interested to explain how you got the result? Of course, I can run the program and you see the output. Anyone? Okay, so the problem is to keep track what variable is where, what scope, and so nastiness is that we use A in this context and then in this context. If this confuses you, you can change the name of the variable anytime you want. You can name this A a different thing to help you avoid ambiguity if under exam situation you consider it's a little bit stressful. But what would be interesting is to try to keep track of memory location. So when the system starts running, main is encounter. As I said, static variables are allocated first. So we have first a static inside function, inside test. And it's set to 3. And then we enter main. And we have local main, local A in main is set to 2. Then test A is invoked. So we have to identify the actual values. When this function is invoked with one argument, it means that it uses a default value for the second argument. Therefore, A is used for X. X is called by reference. Therefore, X is not allocated any memory, and X is another name for this memory, because X is another name for the first argument. But Y, being a local variable in test, is allocated the value 1, being a default value. Now we have all data needed to compute what happens inside the test. I static is 3, X is incremented by the sum of Y and A. Therefore, X is incremented by the local A, remember, which means 3, 2 plus 3, 5, plus Y, 6. So this is the new value of X, which is the new value of A, okay? What about Y? Y, divides integer division. It's not so important here, but be aware we are working with integers. So if I have, in this case we have 6, this is x, divided by a, 3, y is getting the value 2. If I would have 7 for a, 7 divided by 3 is still 2 integers. Anyway, right. And then we go to cout. Cout display the value stored in a. So if we go to what is the output, we have the output here. 3 is displayed, be aware, plus means we increment after displaying. This is how postfix works. We increment to 4, display x, which is 6, comma I think we're doing, and then y, which is 2. Return y is returned discarded. Okay, we haven't stored it anywhere. We just invoke the function test a. We are at the end of this function. Therefore, y is destroyed and x doesn't make any sense. The function is finished. And then we go to the next statement. B is declared inside main and test A is again invoked. So this is the first output. Now we go for the next. A static was there inside main. Now we go a B, which has to be set. That integer B has to use the value of test A. So we start again invoking test A. A is the value of x. They are synonyms. So now x and A are this memory location. Y is recreated, okay, and gets the value 1. And then the static A was 4. X is incremented by A plus Y. 1 plus 4 is 4 plus 1, 5 plus 6, 11 if I am not wrong, right? Y, 1 and A. 5 plus 6, 11. This is X, 11, yes. Then we have Y. Y is X divided by A. X, 11 divided by 4. What is the result? Integer division, 2. If I am not wrong. Okay, so X divided by 4. And now we go to cout and return Y. Y is returned, so B is this value. Oh, sorry, I am skipping cout. Cout, A. A is display and is 4 and incremented to 5. Then we display X, which is 11, right? And then we display Y, which is 2. And then return 2 in B. So this is B and this is 2. Right? Have you got this so far? Right. So this is the output. 362. This is not okay. You can run the program, of course. Properties. this is how you go and talk and try to find the output, because by running the program, you might not get a layout. I was looking at layout. Okay, so 362, 411, 2. The next one, y gets a value of a, so x is done, b, y is out, and then you are left with these values in the memory and keep going. So we stop here. I put 2 more exercises on stream with such a kind of exercises. I strongly recommend you to go over them, because you have to be very familiar with call by value, default parameters. It's 6 marks out of 20, so it's quite significant. Plus, it will come in a class wrapping. It will be a lot of fun. So, please try to solve the exercises I put on stream. It's a file with exercises for call by reference, call by value. We stop here, and we will continue on Wednesday with classes. We start talking about object classes and the real methodology for object-oriented.